Right. Implement let's fill triangle. There we go. I'm gonna push that right into the repo. So now we have the triangle rendering, which is rather cool. So yeah, we can do more things now. I think I forgot to remove the to do, right? Fill triangle. It would be kind of interesting to do a WebAssembly demo as well. Right. WebAssembly demo. Because this entire thing should work perfectly fine in WebAssembly. In fact, like, it doesn't really need any of these things. The only thing it needs is stdint, specifically for uint32t. Right, and maybe even for that, I can probably create like a special alias. And that way, this entire library does not really depend on anything from the standard library, which is actually rather cool as well. Right, we can do something like WASM.c. Right, and that WASM is going to include Olive.c. Right. And obviously we'd have something like width, like so, width and height. And let's define the pixels. Width multiplied by height. So what do we need in here? I feel like we may just have a function that returns the pixels and accepts the render, right? Let's do the fill. Let's fill the entire thing with some sort of a background color, right? This one. And return the pixels that we just rendered, right? So it's a very simple function. And maybe I'm gonna just like go and take the tests. Just go take the tests and render one of the triangles, right? So the triangle that we used for testing should be fine. All right. So this is WASM, and I'm going to also just do clang w-all w-extra target WASM32 minus c WASM c. All right. Let's try to build this entire thing. What do we have? So red color. Let's maybe do something like this. 2020 AA. Right, there we go. And that should have created the WASM file. So this is like literally the WASM file. Does it depend on anything? I think it depends. So let's go and create index.html. Okay. So I think the time has come to maybe change the title to something like Web Dev in C. Now that's what I call a clickbait. Right. So when I was talking about clickbaits, I meant something like this. Okay, so let's do HTML stuff. Alright, so where is the HTML mode? Why don't I see HTML mode? Okay, so this is the head. And then title. All right, so Olive.c. We need to define a canvas, right? Because we're going to be extracting the pixels, we're going to be turning them into image data, and we're going to be putting all of that onto the canvas, right? So we need to put app in here. Canvas, and let's do script src index JS, right? So there we go. Script index JS console log hello world. Might as well, you know, just do app document get element by ID, right? So this is going to be app, and let's just log that thing specifically. I want to also do HTTP server 6969. We'll need that because we're doing WebAssembly. WebAssembly kind of requires that. Not necessarily, but yeah. So here's the canvas. Okay. I want to do this. Let's ctx get context 2D, and this is the context. So we've got the context, so we can draw shit in this context. Interestingly enough, I'm gonna set the width and height to the width and height of the application, right? Let me steal some code from my other stuff. JS load JS. So usually what I do, I keep track of the WebAssembly module that I'm loading up. And I do instantiate streaming. Okay. So what am I fetching? I'm going to be fetching WASM.o, the one that I just generated, right? And here we're going to be establishing the environment. I'm not particularly sure what do we need from the environment, but I have a pretty cool function that allows you to have any environment. Alright, it's just like doesn't matter. So what you can do, I suppose, you can do make environment. And essentially what this thing does, we can take a look at it, is that it uses the proxy and whatever the WebAssembly requires, right, whatever WebAssembly requires, it will just give you the stub that says that this thing is not implemented. All right, so let me see, and then we do then. All right. Okay, and I might as well just do console log w, and let's see if it actually, you know, did the thing. So incorrectly expected application WASM, but this thing did not work properly, which is rather interesting. So why is it not what I think it is? Probably because I did -c. Alright, so maybe I should not do -c. Let's call it WASM. I really like to call it something else, but yeah, let's call it WASM. It's kind of dumb, but it is what it is. Alright, so here we have some problems because we're trying to link with stuff. Our standard lib. I need to get some flags, so let me just find some flags. First, so we do export all, no entry. I think it's no standard library, and then we also have to do something. But this is for the this is for the linker. I don't like that. So this is for the linker. That means I want to do shit like this, and then do wasm ld m wasm32 no entry export all just in case, allow undefined. And we'll see how it goes. So let me see if it's gonna build it properly. Input unused. Yeah, that's true, because it didn't provide this thing. What are you talking about? Feel I'm falling asleep. So, oh, wasm. Why do you say input unused? Are you crazy? What did I fucking miss? I'm sorry. So, let me try to understand. What is input unused? Linker input unused. That's kind of weird. What do you want from me? The must means you pass in linker flags like L, which tells the linker compiler to compile. This means that the result of running is generated link. What is this nonsense? I just want to link some shit and I don't care. Alright. Like I literally couldn't give a less shit. The fuck? So, oh yeah, I think I'm an idiot. Okay, so maybe something like this. Okay, so we managed to do this kind of thing. Alright, so that means in here, what I have to do is just WASM. Would you look at that? Would you look at that? Isn't that epic, chat? Isn't that epic? I know nobody gives a shit. No, I know nobody gives a shit, but I personally think this is epic. Just personally think this is absolutely freaking epic. So we have render, and let me try to call this thing. So this is gonna be an instance. I think, yeah, we have to go into the instance experts, and then I'll have to go render. Right, and if I try to do that, so this is the function that I can call, and if I call this thing, I get the pointer, and that pointer is rather important, right? So because that pointer is the pixels. Right, so that's the pixels, chat. This is the pixels, and what we can do, we need to get the memory. Right, so this is going to be the buffer. W instance experts memory buffer. Let me double check that that's what we have in here. Right, so that's the buffer, that's the memory. So then you int 8 array. So I take the buffer, this is from where I start, and I need to specify the size. So it's basically app width, app height, multiplied by 4 essentially, right? Because that's the size of the entire thing. And let's take a look at that. So these are the pixels of the image we rendered in C in WebAssembly. I know nobody gives a shit, right? So I know nobody watches the stream, but that's what we're doing here. So then what we can do, we can take this array and we can turn it into image data, right? So image data. Let me see. So if I just do that, I can put a data array in there. I wonder if I have to. Yeah, I have to specify at least the size. All right. So this is the data array, and width in our case is essentially app width. Right. So then. Failed image, the source 0 is not a number. Really? Are you freaking serious, my dude? How is that the source width or not a number? Are you crazy? So this is that, and maybe I have to, okay, a clamped array. Clamped. That's what you want? Probably. New image data. and then app width. There you go, we've got the image data. So this is something, I already talked about it, but there is very cool missed opportunity for web tools. Right, so web tools are supposed to be like super cool. They show you the structure of the objects and shit. But you know what they could do? I think I already mentioned that. They could detect that you're trying to console log image data and literally show you the image. That would have been so useful. Right, like you know that this is image data. This is the pixels that are, this is the bytes that are supposed to be interpreted as pixels. Show me the image. Like, just like hover over it and just show me the image. Why not? What stops you from doing that? Doesn't do that. Because, like, I don't want to render it just to see the image, right? Anyway. So let me try to take the image. So this is the image. There we go. And I want to dump that image into the canvas. Right, so this is going to be canvas. Render image. Nobody cares. Yes, nobody cares. As usual. Nobody gives a shit. Trying to make something cool, nobody gives a shit. It is what it is, and it isn't what it isn't. Is it not? I think it is. Image 00. Okay, so let's actually try to render this thing, and boom. No, it didn't work. Fuck. The provide value is not of type. Are you serious, my dude? What the fuck? So this is dx dy. I think image data. Oh, I think there was a put image data, wasn't it? Yeah, it's a put image data. Okay. Put image data. There you go. Doesn't this look familiar, chat? Do you not recognize this thing? Don't you know, recognize this poggers thing? I think it's really poggers. And yeah, so we basically compiled our library to WebAssembly. And we just run this entire algorithm that we developed today for rendering the triangles in WebAssembly. So this thing is truly cross-platform, right? It doesn't depend on anything, so you can just do that. What's interesting is that I think we can even try to animate that, right? So if I go to like WASM.c, for example, in render, we can probably accept delta time, right? It would be also interesting to, for instance, keep track of some sort of a like angle. But for these 2 points, how are we gonna actually rotate them? We can turn them into how is it called? Polar coordinates. Yeah, it would be nice to have something like let me see. Rotate point. We're gonna accept the pointer to x1, well, actually just like x and y, right? Just 2 pointers, right? This is 2 pointers. And in here we can do rotate point x1, y1. We're gonna rotate it by the angle, but the angle is global variable, so maybe I'm gonna just like, you know, it doesn't really feel good, so let's just whatever. No, sorry. Yeah, 3, there we go. So we're gonna be rotating this thing, and every time we do dt, we can do something like, okay, 2 multiplied by pi. Right, so this is the, we can say like a full circle per second, so that means we can do this kind of stuff. You know what I mean? And if we want to rotate the point, Right, so we need to turn it into like a polar coordinate and then add the angle and convert it back. So, but we're gonna do the polar coordinate relative to the center of the screen. So that means we have to do something like minus width half of this thing, right? So this is gonna be that. The same goes for y, right? The same goes for y. Might as well just like do something like this. So this is the center, right? So this is the center. The question is, how do we convert it to the polar coordinate? Polar coordinate is the angle and the magnitude, right? So we can do the magnitude, I'm pretty sure. I wonder if we can do the magnitude, the square of the magnitude, right? So we can do the square of the magnitude. But for the angle, we'll still have to convert to floats, so maybe it doesn't really make sense to do the square, so it doesn't matter. SQRTF, we're starting to depend on math library, which is rather interesting, so we'll have to implement it in JavaScript. So CX. Oh, by the way, I usually call this kind of thing dx and dy. I don't know why I decided not to call it like that. Alright, dx plus dy, so this is the magnitude. And the... what is it usually called? Angle? Well, let's call it angle. I already have the variable angle. What does it consist of? It's a magnitude, vector magnitude and usually length. A vector's magnitude, direction. Yeah, sure. It's usually computed with A10-2, right? So with A10-2. A10 was so good, they made A10-2. Right. Okay, then what we can do, we can add the current angle and we can convert all of that back, right? So by doing cosine of this thing multiplied by mag, and of course it's going to be truncated back to the integer, right? Something like this. Something like this. You know what I mean? Alright, so let's try to build this into everything. Pi, we don't have pi. I wonder if I can just like include math and just hope that it's gonna import math not found. Okay, so that means we have to have like external functions for all of that, right? So let me find them. SQRTF. So this is gonna be that, and I can just like mark them as this. How can I say that I'm gonna be externally? Do I say external? I don't remember, honestly. A10-2. Oh, there's the A10-2F, so that's probably the one that I have to use. Right. So what do we have? So this is a cosine F. So sine F. Okay, and pi, can I just use mpi? I cannot. I'll have to define it as my own. WASM has its creative functions. Is there a way to use it on WebAssembly? I have no idea. I don't think I care about it right now, because what I'm trying to do right now is just have something working, and caring about using very specific instructions when you're trying to make something just working. It's kind of a waste of time. Sorry, I don't know. It's just I'm outlining what needs to be working, right? Once I have something working, maybe we can think about how to make it more optimal. Right now, I don't care. So it's too early to ask such questions. Too early, very, very early. It's just like, no, it's not right such questions are only gonna distract you from doing the thing that needs to be done. Okay, so we need to organize the event. We need to organize the event loop. So let me go place this kind of stuff. So we're gonna keep track of this. So this is the delta time. And the delta time is in what? This is a time step, it's in milliseconds. Is it really in milliseconds? Why I don't divide it by anything? Okay. So... Ooh. Did I accidentally remove the important thing that renders everything? I feel like I did. Where is the render? Oh yeah, here. Oh, I'm such an idiot. Okay, so let's go back. Yes, give me that stuff. Alright, so this is the pixels, this is what we draw, but every time we do that, we also have to do delta time. But the problem with the delta time, I think, is that it's not in milliseconds, so I'll probably have to multiply it by this. Q. Okay. Is it working? Is it working? It doesn't work. It doesn't work. Oh my god, something went horribly. Holy shit. Okay. Okay, it's like generated thousands of errors, and I don't even know what exactly it generated there. It makes it so hard. Okay. I'm gonna just like try to do something like 16 or whatnot. Oh yeah, I know what it needs. Yeah, I know precisely what it needs. It needs the, you know, this QRT and whatnot. Yeah. So A10 to F and whatnot. Yeah. Math A10 to. Right. So we can just put them into the environment in here. So A10 to F, math. A10 to F. Right. So it really didn't like something. Well, I mean, it has to be just A10 too. So then we're gonna have cosine to F. This one is just like, it's not 2F, come on. And the same goes with sine, cosine, sine. There we go. And it kind of works. And it did some fucky wacky, oopsie doopsie, and I know precisely why. Because I did not add the center back. So what I should have done is this thing. Right. This thing where I will do plus, and we'll need to recompile the entire thing. Need to recompile the entire, and as you can see, it's just doing something reasonable, something more or less. Okay, so what if I just do it like that? It's fine. So let's go back to animation. You guys are ready for an epic animation? There we go. This is so cool. This is also very fast as well. Surprisingly, for a triangle being rendered pixel by pixel, this is rather fast, isn't it? So I'm actually have an urge to try to do 3D with this shit. That would be actually kind of interesting to do 3D, right? So, and the whole rotation is also done within like WebAssembly and stuff like that. On a 10 years old laptop, yeah, exactly. So, it's pretty cool. What the fuck? Why is it so fast? Like, especially that I also use like floats and whatnot. And yeah. So, yeah. The only thing you need to do for 3D is to just like project 3D vertices of some 3D mesh onto the 2D screen. And then just use this function to rasterize everything. So, should work. This is because you use the right data structure. Well, I would say this is because I use the right representation of a vector, which is the polar vector. Right. Rotating things, well, rotating polar vectors is actually very, like, it's easier than rotating, you know, Cartesian vectors. That's for sure. Maybe we can make it a little bit slower. I think we need to make it a little bit slower. So yeah, I'm gonna refresh this thing. No, that didn't work. That's opposite of a slower. What about half in here? That is very smooth. Look at that. It's a very smooth triangle. So what's interesting is that I think this is how like graphics, 3D graphics was made like in 90s and stuff like that. People were making like 3D games in 90s. And they didn't have like a GPU acceleration or anything like that, and they quite often just like filled up, you know, memory pixel by pixel. And this is how they did that. So software rendering, yeah, software rendering is so fun. You know why it is fun? Because you don't have to deal with the OpenGL bullshit. What's interesting is that, like, yeah, it's kind of like you pay with the performance, but you get a convenience, and it's kind of interesting. Is that the price that you're willing to pay? What's interesting is that what if you're using like a very modern CPU with AVX 512 and just like use shit ton of CMD instructions? How fast can you get with CPU 3D graphics? By like using like a lot of CMD instructions and stuff like that. You can even have some analog of shaders of some sort. Like you can have small procedures that work on small sub images using CMD instructions and stuff like that, and maybe also parallelize that to several cores and stuff like that. Yeah, that's very interesting. All right, today was a rather interesting stream, wasn't it?